Today's lesson is the start of our similarity unit. Throughout this entire unit, we're going to use these things that you learned about in Algebra 1 called proportions. So a proportion is when you have two ratios, which are fractions, set equal to each other. In Algebra 1 last year, you learned about how to solve a proportion using what is called cross products. In middle school, your teacher probably called it cross multiply and divide. So when you're looking at a proportion like in number 5, all you're going to do is cross multiply your two diagonals, and you're going to set the products equal to each other. That's called cross products. So first diagonal of 2 times 8 will be equal to the second diagonal of 5 times x. 2 times 8 is 16. So if you want to know the value of x, you divide both sides by 5, and we end up with an answer of 16/5. If you want to write that as a decimal, you can. It'd be 3.2. In the next one, same concept still. We're still going to do cross products. The thing that you have to remember here, though, is the x minus 3 is in parentheses when you cross multiply. Because when we solve this, you're going to have to use the distributive property. So my recommendation is always put a denominator with subtraction like that, or a numerator with addition or subtraction like that. Put it in parentheses so that you remember to do the distributive property. So to solve this, multiplying out the 4x minus 12 equals 3x. Since the 3x is on the left by itself, I'm going to subtract 4x from both sides. So negative 12 equals negative x. And if I divide both sides by negative 1, we get x equal to 12. In the next problem, it's a very similar problem. Remember to put the y minus 3 into parentheses so that you remember to use the distributive property when we do this problem. The other diagonal gives me 7y. So the first step for this would be to distribute the 14. Then we're going to, again, group the y's on the same side. So I'm going to subtract 14y. Negative 42 equals negative 7y. And in order to solve for y, we would divide, and we get a value of 6. So that's just a quick review of proportions from Algebra 1. You cross multiply, and you have an equation to solve. Very, very simple. If you need more practice on that, let me know, and I can give you some extra proportion problems. In the next problem, it says you're planning to paint a mural on a rectangular wall. You know the perimeter of the wall is 484 feet, and the ratio between the length and the width is 9:2. What's the area of the wall? Anytime we start a problem like that, you're going to take your ratio of 9:2, and you're going to write it as 9x to 2x. Oops. So what we know about the perimeter of a rectangular wall is that the perimeter is going to be all four sides added together. So if I label all four sides, the total perimeter is supposed to be 484 feet. So I'm just going to take the four sides, add them together, and I should get a total of 484 feet. So 9x, 9x, 2x, and 2x equals 484. If you combine like terms, adding all of those x's together, we should get a total of 22x. That equals 484. And in order to find the value of x, you would simply just divide. And 484 divided by 22 should give you a value of a value of 22. So that's your value of x in the problem. Now it says that that's not the final answer, because the final answer wants to know what the area of the rectangle is. So now that I know what x is, I can plug it in here and find out that this length is 22 times 2, which is 44. I can plug 22 in up here, and 9 times 22 should give me a value of 198. And if I want the area of the wall, it's a rectangle. And to find the area of a rectangle, I just have to multiply. 198 multiplied by 44 is going to give me 8,712 square feet. The next problem is similar. It gives you a ratio again. This time it's giving you a ratio of 1 to 2 to 3, and they represent the measures of the angles of a triangle. So if I take that ratio and write it with x's, it'd be 1x to 2x to 3x. And then you use what you know about a triangle and its angles. We learned in the last unit that if you add up all of the angles in a triangle, you should get 180 degrees. So that's the equation I'm going to use. Adding my x's gives me 6x equals 180 for an x value of 30. Now the problem says that you want to find the measure of all of the angles, so you're just going to simply take that x and plug it in. The first one would be 30 degrees, the second one would be 60 degrees, and the last one would be 90 degrees. 1 times 30, 2 times 30, and 3 times 30. So all we're doing is using what we know about ratios in order to figure out these problems. In the problem on the bottom, this problem says, as part of an environmental study, you need to estimate the number of trees in an acreage of 150 acre area. You count 270 trees in a 2 acre area, and you notice that the trees seem to be evenly distributed. I want you to estimate the number of trees. So what I'm trying to figure out is how many trees, so T trees, in a 150 acre area. What we notice is there are 270 trees in a 2 acre area. So if the trees are evenly distributed, that means I can write a proportion with these two ratios equal. And now this is just a problem like the ones on the top, where we're going to solve using cross products. So 2 times T, and then we're going to multiply 150 and 270, and we should get 40,500. So if you want to estimate the number of trees, there should be approximately 20,250 trees in that 270 acre area. That's a whole lot easier to estimate something like that when we're talking about a huge number like this, rather than actually going through the acreaged area and counting each individual tree. So this just gives us an estimation of what we would have approximately counted walking through the area. On the back, we're going to talk about some geometric pictures. So the thing about proportions is you want to match up what's alike. So in this particular picture, 105 and X are alike because they're both the base of the buildings. X and 210 are alike because they are the heights of the buildings. Now notice when I wrote these, since I put the 105 on the first top, that means that the X has to go on the second top because they're both from the smaller building. Since the X went on the bottom for the base numbers, the 210 has to go on the bottom because they both represent the larger building. In order to solve this, you're just going to use cross products. Now when I cross product the X and the X, we should get X squared. So we have to use a little bit of Algebra 1 knowledge to make sure that we remember how to do this. X times X is X squared. And if I multiply 105 and 210, I get 22,050. Now going back to what we know about Algebra 1, all we're going to do now to get X by itself is take the square root. So if I take the square root of that number, we are going to end up with a value of 148.5. And that would be in meters. So what they're saying is the base of the larger building and the height of the smaller building are actually the same distance, that distance being 148.5 meters. In the next problem, we have a picture of a triangle, and we are just going to match up using the proportion that they provide for us. So all we're going to do is match up what they have there. So I'm going to have my proportion, and I'm just going to fill in the blank spaces. So let's start with the easy ones. DA is clearly labeled as 3. EC is clearly labeled as 6. BE is clearly labeled as 18. The tricky one is BD. We're told this entire length is x, and this bottom portion is 3, which means this missing piece is the whole length minus that extra 3. So x minus 3. That's really the only tricky part of the problem, is figuring out what goes in that top left corner. So it says find BA and BD. So the first thing we're going to do is solve for x by using cross products. So the first cross product, remember we need to put the x minus 3 into parentheses. The other cross product, if I multiply 3 and 18, we get 54. By distributing the 6 on the the left side, we end up with 6x minus 18 equals 54. If I add 18 to the other side, we end up with a value of 72. And if I divide both sides by 6, my x value comes out 12. Now, remember, we always want to answer what the problem is asking. The problem says find BA and BD. So BA was the entire length x, which would mean that's 12, because that's what x came out as. And then BD, we said, was x minus 3. So 12 minus 3 gives me a BD length of 9. The last thing that we're going to talk about down here is scale drawings. Now, all of you have seen a scale drawing. Anytime you look at something like Google Maps or MapQuest, or if you pull out an old paper map, you're looking at a scaled drawing. Obviously, if you're going to look at a picture of the state of Missouri, you're not going to have a real-life picture of the state of Missouri because you wouldn't have enough paper to draw it. So map makers back in the day took the states and the United States and the world, and they scaled them down so that they can fit on a piece of paper. So normally, in a scale or in a drawing, you're going to see a scale that tells you if you measure 2 inches on this picture, it actually represents 19 miles in real life. So every 2 inches on my picture, you're actually traveling 19 miles if I was actually driving a car or walking the distance. And that's true of any map. Most maps say every centimeter is 10 miles or 2 centimeters is 15 miles, something like that. So you can usually find those in the bottom left or right corner of the map or the scale. So this says I want to know the distance between these 2 towns. If on this picture I laid a ruler down, it was 2.3 inches. So all we're going to do is write down a proportion. So 2 inches makes 19 miles. And we're going to do 2.3 inches is how many miles? So if you want to replace that question mark with something from math, we would replace it with an x. So 2.3 over x. And this again is just a problem where we're going to use cross products. So all we're going to do is cross multiply 2 and x. And we're going to cross multiply 19 and 2.3. And if I divide both sides by 2, we find out in actual distance that it's approximately 21.85 miles. So if I was actually to get in my car and drive the distance, or if I was just going to walk a straight line distance, it would take me almost 22 miles to get there, even though on the piece of paper it's only 2.3 inches apart. But in real life, it'd be about 22 miles. The last problem. It says you buy a 3D scale model of the Reunion Tower in Dallas, Texas. The actual building is 560 feet tall. Your model is 10 inches tall. The diameter of the dome on your scale is about 2.1 inches. What is the diameter of the actual dome? So the things that we know in the problem. We have some measurements of the actual building. We know how tall it is. We're trying to figure out what the diameter of the actual dome is. We also are told that your scale drawing is 10 inches tall and the dome on that scale is 2.1 inches. So what I've done is I've highlighted the things in the different colors that we're going to put together into the proportion. So we are going to do the blue ones together as height of my model over the dome size of my model, and that should be equal to the height of my figure over the actual dome size of my figure. And I'm going to replace that h with an x. So if I want to solve to figure out how far across that dome is on the actual figure, all I'm going to have to do is cross multiply. 10 and x gives me 10x. 560 multiplied by 2.1 is going to give me 1176, which means that if I solve for x, I'm going to get 117.6, and our actual building is measured in feet. So if the building is 560 feet tall, its dome all the way across is 117 feet, almost 118 feet. The last thing is it says, part B, how many times as tall as your model is the actual building? Now here's the deal with doing this. In order to do part B, we actually have to take the two heights and we have to put them into the same unit. So what I'm going to do is I'm going to change them both into inches. So the building height is 560 feet. Now in order to change that into inches, there's 12 inches in every foot, so I'm going to multiply by 12. So 560 multiplied by 12 is 6720. That's how many inches tall that building is. Luckily, my model is already in inches. My model height is 10 inches. So since I have them both in the same unit, all I have to do to figure out the how many times taller the building is, all I have to do is divide the numbers. So 6720 divided by 10 is 672 times as tall. So in other words, if I took the model that I had, if I stacked them on top of each other, I'd need 672 of those models in order to reach the height of the building. So if I stacked them from the ground up, 672 of them would stack from the bottom of the building all the way to the very tip top of the building. As always, if you have questions about any of the problems, why I did something, or how do I solve a proportion, I don't really remember that from Algebra 1, those types of questions, make sure you make note of them so that in class when I ask, you have a specific question to ask so that I can help you better. If you have questions, let me know.